Hey guys, hello and welcome to a new video. This time a solve for a Road to Las Vegas case. In this case, a memory game. It's the second case for the 2026 season. And yeah, basically you have there a grid with memory cards, so you know those cards you turn around and try to find matches. And yeah, everything except level 7 and bonus and the related bonus was doable. Level 7 is also doable, I would say, but it has a lot of edge cases, which makes it heavy. But yeah, let's start right into it. How often does those things appear? Count if as. This is the grid, and yes, I should have named this grid probably, but you know, I like going into tabs. Then easy indirect. This is my lambda. I've covered this lambda on my channel. You will hopefully find it now in the corner somewhere if I remember to do this. It's basically map and indirect combined, which can then also spill for multiple cells and makes it easier to include sheet names. Then, how many points does the player have after the given turn? And I reverted here to a table solution, but you don't need this. What I simply did was wrap rows of this area here with 2. Wow. And then you get here this table. So you see we have 2 matches, then we have non-match, then we have a match, and you see the same order here. And now I can say the following. Put this in a let and say take W1 equals take W minus 1 and true false, and then sum minus minus. And sorry, I think it might be annoying to hear the sound of the ventilator here from my laptop, but otherwise it is super laggy. Okay, you see everything solved. Basically wrap rows and sum. You can't use sum and here comparison. When you look at the grid from the top row to the bottom row, in which row will you first find the given symbol? I did the following. I used the grid, and yes, by then I should have named this grid. Used array to text, which is concatenation, but I did this for the grid where I made here the text by swapping the symbol against the text. Forgot about this. And then I used a search of this text in my concatenation and then did an X match for true if here is a number. So X match true is number will give you then the needed result. Drag down, here we go. Medium. One player in the game, player is not ready. How many games? Here I was able to use one of my newest lambdas, but I will show you this. So column delimiter is the, I don't know, I say double point. I don't think it is the right name for this here, but it's my bad German translation. If you know the right term, feel free to write it in the comments. And then, as promised, one of my lambdas, it's called area based on addresses. Address 1, even can use a sheet name here and indirect, and I directly get here the areas. Then to call of all of this, name this T, and then I used group by TT count A. Sort order doesn't matter, but we don't want totals. I don't know why the standard is having totals, doesn't make sense, but and then I take the second column or the column from the right, and then divide this by 2 and round down, because if you have 2, 4, 6 and so on memory cards, you can do matches. And then sum. And this is then basically something we can copy down here and get to our answers. Level 6 is a little bit more trickier, and therefore I will revert to data tables. And yes, I have to fix this data table match here. I think I fixed it for if you have here letters, but yeah. Anyways, because some people tend to do example 6A, 6B, 6C, and so on. So here, those are the lucky cards, those are the cards. Players take turn and open 2 cards. If they score a point, they will take another turn. Otherwise, yeah. So all these are the rules that you can follow along. So player, in this case, it's 1 for the first one, and point. So I make a track down solution, and you have to watch out for one thing. The example isn't the same length as the whole grid. That's something to watch out, but I will track it. Now with the header, I know how far to drag it. So here this is true because both cards are the same, and then simply drag this to the side and try to match every second card. Yes, I know. This might be an issue for the example. So let's say the following: if this is unequal to nothing, then make this, otherwise 0. Yeah, okay. Oh, we have to track this. I know, annoying, but sometimes easy solutions, as you might see for level 7, are better than hard solutions. So here is the point is the no point. And now we say if this is nothing, then take the if this is true, take the previous player. Otherwise, if this equals 1, then make 2. Otherwise, make 1. And if this is nothing, if this is something. Oh, yeah, okay, yeah. Otherwise, if this is something, then take the previous player. Okay, this equals okay, there's something odd. Okay, start from the beginning. So if we're here, then not in the in the first turn, so to say, then if this equals true, then take this player. Otherwise, if this player is 1, make it the second player. Otherwise, revert back to 1. And Yeah, otherwise take this here, take this player here. Okay, 1 here, then 2, 2, 1, 1, 1 again. Yeah. Okay, track this as far as needed. So, and then player 1, player 2. Lucky card, lucky card. This equals lucky card of player 1. And now watch out. You actually should then also adjust for the lucky card of player 2, not as I did. So, and then we do a scan. Are we actually? Yeah, we have to scan. Oh no, track. 1 point, player 2 points. So 0, 0. If this equals, if this is true, then if nah. So if the current player is 1, then if this equals true, then if this is the lucky card, then take the previous plus 1 times 2, as stated here. Otherwise, take the previous plus 1. Otherwise, take the previous. Otherwise, take the previous. And then simply adjust for player 2 and track this to the side. Oh, I haven't tracked this. Yeah, this makes sense because this is no, this is not dynamic. Drop here the first columns. And here drop also the first, but check with the player here. Oh, both have 6. No, this can't be. What went wrong? Okay, why? Okay. Okay, I have broke this here. Okay, I have to check thoroughly. So we're here. If this is player 1, then is a point scored? Yes. Is a point scored? Yes. Then is this the lucky card? If is this the lucky card, then plus 1 times 2. Otherwise, if it's not the lucky card but still a point scored, previous score plus 1. Otherwise, previous score. And I think that was a copy issue. No. Should not be a copy issue. But here, there cannot be a point score here. I should then also adjust here for player 1 running or score before, player 2 score before. But at least something you check by then. And then absolute difference of this minus this. It's in this case 5, which is the same as in the example. And now use data table 120 b1 b4, and it should be solved in an instance. Why is this taking so long? Okay. Let's hope it's right. Yeah, everything right. Okay, before I do level 7, I jump to the bonus questions 1 to 4. Which symbol has only one matching pair in the grid? Provide the name as the symbol, not the name. So group by to call, and yes, annoying to always refer to the grid. I think after going back and doing this case again, I should definitely have named this something. Then count A and sort order -2. Not -2, 2. Sorry. Yeah. And this is then the trophy. Which symbol never gets matched across all level 3 games? Which symbol? Provide the answer as symbol, not the name. Okay, how did I do this? Okay. What you basically can do is to row. I've solved this before. To row of everything and then wrap rows 2. Yes, this will spill. Let W drop W1 equals drop W -1. Yes, I know, not the best way. And then we have this, is there a match? And then we How did I and this hasn't appeared as complicated to me last time. But I might be out of brain power. Match, name this M. And now filter drop W1 if match equals 0. No, this should be right. Okay. Well, I can't. Okay. This is idiotic, but to row. I promise my live attempt of this was way better. So wrap rows. And then we say this equals this. False. Filter this if this equals 0. No. Normally this should work. Anyways, and then no, this equals 2. And then we simply count which of those is not in there. List not in list. And it's the pizza. Sorry, this was utterly complicated. Now, which symbol would you encounter last if you went through the grid rows from left to right, top to bottom? There are 2 interpretations of this. So first, you can do the following. You say, okay, I go by grid, by row, and this would mean by row and then top to bottom. And this would mean, as you can see here, going there in those directions. But also, if you take this in order and read over this here, then you say from left to right, top to bottom. 2, 3, and this would mean to call, and then there is here scan by column, and this would mean you go those directions, and both are leading to different answers. I think the intended version was the first one, and I simply did then here count x match, and as you will see in an instance, so I do sort. In this case, the sort index is 2, and here, and then there's the option the trophy, but if you sort after the third column, it will be the bell. Both is kind of possible. In this case, I take the trophy. Now, please read here that this relates to this level, because I thought, oh, why not do this here, but simply delete here every second column. But you can basically, because it's not related to the level 5 inputs, yes, level 5 inputs, I simply again deleted the columns here. It's enough to delete them. You can also do sequence mod and then filter them or something like that. But I simply copied the sheet and deleted them. That was the fastest option. And then you can still use to call ignore blanks, because now they're really blank. And what was asked? How many matching pairs? And that is wrong. Matching pairs, and then I used again group by count a sort order doesn't matter, but no totals, and then round down this divided by 2, and you get to 214. Yes, and now the hardest part, so to say, the level 7. And for level 7, I will not do this live here because it's not error prone. I will show you my model I've built. So basically, you're in level 7, you're really playing memory. So 2 players, player 1 will start. They will open a card, and if this card does not match a previous card that wasn't matched, then they will open another one. And if there's no match, okay, then both cards will be turned, like really playing memory. And there's another thing, if you they will not open a card if the previous second card of the previous player wasn't matched. So they know, okay, there is a match in there. I know where the match is because they remember everything. And they then say, okay, I will not open a new card. I will go back to those 2 unopened cards that I can match. And I did this via a data table. Okay, this is not important anymore. And here, I will not show you this at the example. So here, the card order is given in the string. So what I did, I splitted this, I used easy indirect, and I got these symbols. Then, because I did a sequence, a rows text split, I know that these are always 900 rows. So except for the example, which is so shorter, these are 900 rows. So sequence 900. Then here again the cell and the symbol. And then I did the following. Okay, player 1 will always start. We know this. And also here the draw is 1 or 2, his first draw and his second draw, because it cannot go to further draws further up, further unmatched cards, because there were no further unmatched cards. And then, okay, 0, 0, 0, 0, and here we check the following. Now, this is kind of one of the main formulas, so I say the following. If the draw is 2, then I check, is the previous opened card and the now opened card the same? Then he gets a point. The current player gets a point, otherwise no point. And I do the following. When the count of, and this is here a track down count, of the cards of the, because here I'm in first draw mode now, because I'm in the fourth argument. If there is an uneven number of the same cards in the previous opened cards, then I also get a point, otherwise I get no point. Why do I get also another point? Because basically there are no unopened even, because how can I explain this? Because let's say, is there an example for this? Yeah, let's use this here. So here player 2 has opened here a cherry card, and the first card that player 2 has opened again is then a cherry, and then he remembers, oh, I've opened a cherry before, I go back to this, and therefore I know, okay, here's an uneven number of cherry cards, so an odd number of cherry cards, and because this number was odd, no one has opened it before. That's the main point, because otherwise it would have been opened before, and this opportunity would have been exploited if the number is even. And then there's the second term, if this is, so, and this is then the points scored by a player in that round. And then we have the second thing here stated in the rules. If during a turn no match is made, and the second opened card can be matched with another previous opened unmatched card, the next player will use that information. And that is modeled here. So I say the following. There were no points scored by the player in that round. We know this. And then we say, okay, now do the following. Is there now an uneven number of cards in the stack? So the same logic. Then the next player will exploit it. Otherwise, no points. Otherwise, no points. And then I have here the simple running total. So here, when player 1 is in lead, then he gets the points from the previous points plus the points scored in that turn. Otherwise, if player 2 is in lead, then player 1 gets the points from before plus the exploitation points, I name them that way. Otherwise, simply the points from before, so running total in that sense. And basically the same for player 2, except adjusted. So here, if player 2 is in lead, then he gets his points. Otherwise, he can only exploit is if player 1 is in lead, and of course his previous his or her previous sum. So I've explained those. Okay, and now we only have to model two other things. the player and the draw. So here this is determined, no issue, but here it gets a little bit more trickier. So we say the following. If there was a point scored by the player in the previous round, then we switch the players. So if player 1 has scored a point, then it goes to player 2, otherwise it goes to player 1. And then if the player has exploited, if the other player, because we in time-wise we say the other player is following, then if the other player has exploited the opportunities, then we simply take the player from the player is still playing, because basically the other player has made a move, but by this move he hasn't opened new cards. This is this part here, and then we say, okay, if this still not is, so no one has scored a point in the previous round, then we say if this is in turn 2, so in draw 2 or turn 2, I don't know which is the right term, then we simply swap out. So if it's player 1, then it becomes player 2, otherwise it gets a player 1. Otherwise we take the player from before, because then it was draw 1 where there were no points scored. Yes, that's what this. Also drag down to the bottom those 900 rows. And then for the draw, it's a basic formula. We say the following. If there was a point scored, then we start with round 1. Otherwise, if it is, and point scored mean either point scored by the player in this round or by the following player in exploitation mode. And otherwise we swap. So if it's draw 2, it becomes draw 1. Otherwise it gets draw 2. So basically a reset if there was a point scored. And we track this down too. And now there's one single thing we have to remember, because basically this exploitation mode means in the next round, and logically you cannot exploit something after the last turn. So after 900 turns it's over, and therefore simply we have to put in here a hard-coded 0 in, because there is no following player and therefore cannot be an opportunity to be exploited. And yeah, everything dragged down. You have the solution here, and then we basically say, okay, if this is player 2, then take the points from player 2, otherwise take the points from player 1. And then we use data table, or in this case my data table mimic macro, to create here or to calculate this for those instances. And we will be there in a second. Yes, calculated, copy, and I should now go back to the YouTube solve sheet, and you see here everything right. And now bonus 5 is also quite easy. I will show you this here. So what I simply did, I used my data table from level 7 and copied it. And then here, this is 100%, as we discussed now, the formulas. And then I simply say, okay, was there a point made? So is there a point difference for player 1? Because player 1 is only the player of interest. Where is it here? How many frog matches does player 1 have? And then I simply say, was there a point made? Because there's a point difference. Because I then do not have to work with those exploitation stuff and so on here. And yeah, then I simply say, okay, if there was a point made, then use the symbol that was in that row. In this case, I get all the symbols. And then I simply didn't count if S for the frog symbol, in this case 4. So in the 121 game. There were four frog matches, and then again data table for everything. And then the sum is 88, and this is the answer for the game. And we have solved. It took me a little bit more than 30 minutes, and especially the model in level 7 took me a few iterations to get everything right, honestly. Yeah, therefore I've also did this not live, so to not bore you out with the errors I might have made. And yeah, I hope this mode was also fine with you. Write down in the comments if your model was better, more efficient, or if you don't like this mode with me explaining only the model I've made for harder levels. But otherwise, I will make errors, especially with explaining some stuff and having mental capacity shifted to that and talking English. But yeah, besides that, thank you for your attention. I hope you did well in this round. I did not do that good. I'm not qualified yet for the championship, but yeah, let's see. Anyways, thank you for your attention. See you next time. Bye.